The question that I have is, could you do an example on calculating the vertical stress change due to a circular loaded area? So in this picture, the footing pressure is little q, and we are interested in calculating the vertical stress change at any point below the footing. And here is a common point, and this point lies at a radius r, little r, from the center of the footing and at a depth of z from the loaded area. The procedure of calculating delta sigma z is best illustrated through an example. So let's do an example. So in this example, we have a cylindrical water tank having a radius of 4 meters. The height of water in the tank is 5 meters. We know the density of water is 9.81 kilonewton per meter cube, right? And then I can calculate the contact pressure between the tank and the soil simply by using the formula gamma times H. I get a value of 49.05 for it. In the book, the solutions for a circular loaded area is given in the form of a table. Just for convenience, I'm going to use a chart here. This chart is from the book by Holtz and Kovacs. In this chart, the vertical axis represents the ratio between Z and R, and each of these curves corresponds to the ratio between X and R. So once we calculate these two ratios, we can go to this chart and find the influence value I. So once we have the influence value, we simply multiply that by the contact pressure Q and divide the whole thing by 100 in order to get the change in the vertical stress. Since I want to do this at 4 different points, it's better done in a table. So here's my little table. We know the depth for all the 4 points is a constant, 2 meters. We know the radius of the tank is obviously a constant, which is 4 meters. The X, the horizontal distance, varies for these 4 points, so they are listed here. And first I calculate the ratio between Z and R. Z is 2 meters, R is 4 meters, so Z over R is 0.5. So all the 4 points have the same ratio, 0.5. And the next column has a ratio between X and R. When X is 0, the ratio is 0. When X is 2, we have 2 over 4, which is 0.5, and so on. So you calculate the rest of it similarly. Then for each of these pairs, we go to the chart and find the influence value. Let me just do it for one of them. Let me just take this third point right here, right? Z over R is 0.5, so that is right there. So you're talking about this horizontal line. We go all the way to where this line intersects the curve corresponding to the ratio X over R equals 1, right? So that is right there. This curve corresponds to X over R equals 1. So at this point, my influence value is 41. So the rest of the calculations are pretty straightforward. We already calculated Q, which is 49.05. So you put that over here, multiply that by the influence value, divide that by 100. How do I know I need to divide this by 100? Well, the formula for this specific chart is given right here. So you just go by the specific formula that is given for you.